Top 30 Electrical Engineer Interview Questions and Answers. Preparing for an electrical engineering interview requires strong technical knowledge, problem-solving abilities, and clear communication skills. Employers often assess candidates on their expertise in electrical systems, safety standards, troubleshooting, and project management. In this guide, we present the top 30 electrical engineer interview questions along with professional answers. These will help you understand what hiring managers expect, refine your responses, and boost confidence for your upcoming interview. 1. Can you describe your experience as an electrical engineer? I have worked on diverse projects involving power distribution, circuit design, and electrical system troubleshooting. My experience includes designing control systems, ensuring compliance with safety codes, and collaborating with cross-functional teams. I've been responsible for improving system efficiency and reliability through innovative solutions. Additionally, I've handled maintenance and testing of electrical equipment, which strengthen my diagnostic skills. My background allows me to adapt to different project requirements and provide effective solutions to complex technical challenges. 2. What are your key strengths as an electrical engineer? My key strengths include strong analytical skills, attention to detail, and the ability to apply theoretical knowledge to practical applications. I excel in circuit design, power system analysis, and project planning. I also have excellent troubleshooting abilities, allowing me to identify and resolve issues quickly. Moreover, I am highly organized, efficient in time management, and capable of working collaboratively in team environments, which ensures project success within given deadlines and quality standards. 3. How do you ensure electrical safety in your projects? I prioritize safety by following national electrical codes, standards, and organizational safety policies. I conduct risk assessments, identify hazards, and implement preventive measures such as grounding, insulation, and protective devices. Regular testing and inspections are performed to verify system integrity. I also ensure all team members are trained in safety protocols and use proper personal protective equipment. Adhering to safety guidelines helps minimize risks, prevent accidents, and maintain compliance with regulatory standards at all times. 4. What tools and software are you proficient in? I am proficient in electrical design and simulation software, such as AutoCAD Electrical, MATLAB, PSpice, and EDAP. I frequently use these tools to model, analyze, and optimize electrical systems. I am also skilled in PLC programming and SCADA systems for automation projects. Additionally, I use Microsoft Project for scheduling and management. These tools enhance my ability to design accurate systems, troubleshoot efficiently, and deliver projects with precision while meeting client requirements. 5. Can you explain the difference between a circuit breaker and a fuse? A fuse is a single-use protective device that melts when current exceeds its rated limit, breaking the circuit. It's simple, inexpensive, and effective, but requires replacement after operation. A circuit breaker, however, is a reusable protective switch that trips when current overloads or faults occur. It can be reset manually or automatically, making it more convenient for long-term use. Circuit breakers are also more advanced, offering adjustable settings and better fault detection features. 6. How do you troubleshoot a faulty circuit? I begin by reviewing circuit diagrams and understanding the system layout. Using a multimeter, I check voltage, current, and resistance at various points to locate irregularities. I systematically isolate sections of the circuit to narrow down the problem. Common issues like short circuits, loose connections, or faulty components are then identified and resolved. After repairs, I test the circuit thoroughly to ensure functionality and safety before putting it back into service. 7. What is the importance of grounding in electrical systems? Grounding ensures safety by directing fault currents safely into the earth, preventing electric shocks and equipment damage. It stabilizes voltage levels during normal operation and reduces the risk of fire caused by electrical faults. Grounding also protects sensitive equipment from voltage surges and lightning strikes. In industrial systems, proper grounding is crucial for reliable operation and compliance with safety standards. Without grounding, systems are more prone to dangerous failures and hazards. 8. How do you handle tight deadlines in engineering projects? I manage tight deadlines by breaking tasks into smaller milestones, prioritizing critical activities, and using project management tools to track progress. Effective communication with team members ensures responsibilities are clear and potential delays are addressed early. I remain focused, organized, and adaptable, reallocating resources when necessary. Maintaining a balance between speed and quality helps deliver accurate results within deadlines while ensuring safety, compliance, and client satisfaction without compromising technical standards. 9. What's the difference between single-phase and three-phase systems? A single-phase system uses one alternating voltage waveform and is commonly used for residential and light commercial applications. It is simpler and cheaper, but less efficient for heavy loads. A three-phase system, on the other hand, uses three alternating voltages offset by 120 degrees. It delivers consistent power, supports higher loads, and is more efficient for industrial and commercial use. Three-phase systems reduce energy losses and ensure smoother motor operation. 10. How do you keep up with advancements in electrical engineering? I regularly read technical journals, attend webinars, and participate in industry conferences to stay updated. I also take online courses and certifications to enhance my skills in areas such as renewable energy, smart grids, and automation. Networking with peers and joining professional organizations like IEEE helps me exchange knowledge and learn emerging trends. This proactive approach ensures that my skills remain relevant and I can implement modern solutions effectively in projects. 11. What are harmonics in electrical systems? Harmonics are unwanted frequency components in electrical systems, typically multiples of the fundamental frequency. They are caused by nonlinear loads like variable frequency drives, rectifiers, and electronic equipment. Harmonics distort voltage and current waveforms, leading to overheating, equipment malfunction, and reduced efficiency. Engineers mitigate harmonics using filters, proper load balancing, and harmonic-resistant equipment. Controlling harmonics is essential for maintaining power quality, improving system reliability, and ensuring compliance with industry standards and safety regulations. 12. Can you explain the function of a transformer? A transformer transfers electrical energy between circuits through electromagnetic induction. It can step up voltage for efficient long-distance transmission or step it down for safe local distribution. Transformers also provide isolation between circuits for safety. They consist of primary and secondary windings around a magnetic core. Efficiency and reliability depend on design, insulation, and cooling. Transformers are critical in power systems, ensuring voltage compatibility and minimizing losses across electrical networks. 13. How do you calculate electrical load for a building? I calculate load by listing all equipment and appliances, determining their power ratings, and considering usage diversity factors. Loads are categorized into lighting, heating, cooling, and equipment. Peak demand is estimated by summing adjusted loads, applying demand factors, and adding safety margins. I also reference building codes and standards to ensure compliance. Proper load calculation ensures correct sizing of transformers, cables, and protective devices, which prevents overloads and enhances system efficiency and safety. 14. What is a relay and why is it used? A relay is an electrically operated switch that uses an electromagnetic coil to open or close contacts. It allows a low-power control signal to operate high-power circuits safely. Relays provide electrical isolation, fault detection, and automatic switching functions. They are widely used in protection systems, automation, and motor control. By responding quickly to abnormal conditions, relays protect equipment and ensure operational safety, making them a vital component in modern electrical systems. 15. How do you test insulation resistance? I use a megometer, insulation tester, to apply a DC voltage across the insulation and measure resistance. A high resistance value indicates good insulation, while low resistance suggests deterioration or moisture ingress. Testing is performed at regular intervals during maintenance to ensure system safety. Results are compared against manufacturer standards or regulatory requirements. Insulation resistance testing prevents equipment failures, reduces risks of electric shock, and prolongs the service life of electrical systems. 16. Explain the difference between AC and DC. AC, alternating current, changes direction periodically, while DC, direct current, flows in one constant direction. AC is commonly used for power transmission, because it can be stepped up or down using transformers, reducing losses over long distances. DC is more stable and is often used in batteries, electronics, and renewable systems. Each has advantages: AC for efficient distribution, and DC for applications requiring stable, low-voltage power or energy storage systems. 17. What is power factor and why is it important? Power factor is the ratio of real power, kW, to apparent power, kVA, in an electrical system. A high power factor means efficient use of electrical energy, while a low power factor indicates wasted capacity due to reactive power. Low power factor increases losses, reduces efficiency, and may incur utility penalties. Engineers improve power factor using capacitor banks, synchronous condensers, or power electronics. Maintaining high power factor ensures cost savings and system reliability. 18. How do you approach project management in electrical engineering? I start by understanding project requirements, setting realistic timelines, and allocating resources effectively. Using tools like MS Project, I create schedules, assign tasks, and monitor progress. Regular communication with stakeholders ensures alignment and prevents delays. I also perform risk assessments to prepare mitigation strategies. Quality control and safety compliance are integrated into every stage. My approach balances technical accuracy, time management, and collaboration, ensuring successful project delivery within deadlines and budgets. 19. What is the role of circuit protection devices? Circuit protection devices, such as fuses, circuit breakers, and relays, safeguard electrical systems from overloads, short circuits, and faults. They detect abnormal conditions and interrupt current flow, preventing equipment damage and reducing fire and shock hazards. Protection devices also ensure operational continuity by isolating faulty sections without affecting the entire system. Proper selection and coordination of these devices are crucial for safety, reliability, and compliance with electrical standards in residential, commercial, and industrial applications. 20. How do you design an electrical system for energy efficiency? I start with accurate load analysis and proper equipment sizing to avoid energy waste. I incorporate energy-efficient devices, such as LED lighting, variable frequency drives, and high-efficiency motors. Power factor correction and harmonic filters are used to optimize performance. I also design systems with renewable energy integration and smart controls for automation. Regular monitoring and preventive maintenance ensure continued efficiency. The goal is to reduce operating costs while maintaining reliability and sustainability. 21. What challenges have you faced in electrical projects? One challenge I encountered was unexpected equipment failure during a project. It caused delays, but I quickly analyzed the issue, identified faulty components, and source replacements. I coordinated with vendors and adjusted the schedule to minimize downtime. Another challenge involved designing within budget constraints, which I managed by selecting cost-effective yet reliable alternatives. These experiences taught me adaptability, resourcefulness, and effective communication, all crucial for overcoming obstacles in engineering projects successfully. 22. How do you ensure compliance with electrical codes? I strictly follow standards such as NEC, IEC, and local regulations. During design, I reference applicable codes to guide equipment selection, wiring methods, and protection strategies. Inspections and testing are conducted at every stage to ensure compliance. I also attend training sessions to stay updated on code revisions. Documenting all processes and certifications ensures transparency. Following codes not only guarantees safety but also builds client trust and ensures regulatory approval for projects. 23. Explain the working principle of an induction motor. An induction motor operates on the principle of electromagnetic induction. When alternating current flows through the stator windings, it produces a rotating magnetic field. This field induces a current in the rotor, creating torque that causes it to rotate. Induction motors are widely used due to their simple design, durability, and low maintenance. They are efficient for industrial applications like pumps, fans, and conveyors, offering reliable performance in diverse operating conditions. 24. What's the role of PLC in automation? A PLC, programmable logic controller, is an industrial computer used to control machinery and processes. It receives input signals from sensors, processes them using program logic, and sends outputs to actuators. PLCs are essential in automation for their reliability, flexibility, and real-time response. They simplify complex operations, reduce human error, and improve productivity. With advancements in connectivity, PLCs now integrate with SCADA and IoT systems, enabling smarter, data-driven industrial automation solutions. 25. How do you manage electrical maintenance tasks? I follow a preventive maintenance schedule to inspect, test, and service electrical equipment regularly. Tasks include checking insulation resistance, tightening connections, cleaning components, and testing protective devices. Predictive maintenance techniques, like thermal imaging and vibration analysis, help detect issues before failures occur. I also document all maintenance activities for tracking and compliance. Effective planning and execution reduce downtime, enhance system reliability, and extend equipment life while ensuring workplace safety. 26. What is the difference between a generator and an alternator? A generator converts mechanical energy into electrical energy, usually producing DC power, while an alternator specifically generates AC power. Generators use a commutator to produce direct current, whereas alternators use slip rings for alternating current output. Alternators are more efficient, compact, and capable of producing higher voltage for modern applications. Both are widely used depending on the requirement, with generators suited for older systems and alternators preferred in vehicles and power plants. 27. How do you ensure quality in your engineering designs? I follow a structured process that includes thorough research, accurate calculations, and adherence to standards. Peer reviews and simulations validate design accuracy before implementation. I use checklists to verify compliance with codes, client specifications, and safety requirements. Quality assurance also involves continuous feedback from clients and team members. I document every stage for traceability. By maintaining attention to detail and incorporating rigorous testing, I ensure that my designs are safe, efficient, and reliable. 28. Can you explain the concept of short-circuit analysis? Short-circuit analysis calculates fault currents in an electrical system to ensure protected devices operate correctly during faults. It determines the magnitude and duration of fault currents, which helps in selecting appropriate circuit breakers, fuses, and relays. This analysis also prevents equipment damage by ensuring systems can withstand fault conditions. Software tools like EDAP are commonly used. Regular analysis is essential when upgrading or expanding systems to maintain safety and compliance with standards. 29. What motivates you to work as an electrical engineer? I am motivated by the opportunity to solve complex problems and contribute to innovations that impact everyday life. Electrical engineering combines creativity and technical expertise, allowing me to design efficient, safe, and sustainable systems. I enjoy working on diverse projects, from power distribution to automation, and continuously learning new technologies. The ability to improve efficiency, reduce costs, and ensure safety drives my passion for this field, keeping me committed and inspired. 30. Where do you see yourself in 5 years as an electrical engineer? In 5 years, I see myself as a skilled and experienced electrical engineer, leading projects and mentoring junior engineers. I plan to deepen my expertise in renewable energy and automation while staying updated with industry trends. I aim to contribute innovative solutions that enhance efficiency and sustainability. Additionally, I hope to take on greater leadership responsibilities, working closely with clients and teams to deliver impactful engineering solutions and support organizational growth. Electrical engineering interviews test both technical expertise and problem-solving capabilities. By preparing well-structured answers to common questions, candidates can showcase their skills, confidence, and ability to handle challenges. This list of 30 questions and answers provides a strong foundation to excel in interviews, whether for entry-level or experienced positions. With thorough preparation, clear communication, and a focus on safety and innovation, you can impress employers and secure success in your engineering career.